Hey there, Alejandro. Welcome back for the 349 of me doing Daily LeetCode Challenge at 31 years worth of green contributions here on GitHub. So today's round is for June 30th, 2025. Without further ado, let's get straight into it. Okay, this one's going to be exciting because it's going to be the last day of the month. We get a LeetCode easy. I really expected a LeetCode hard today. Okay, problem 594, longest harmonious subsequence. I see the word longest, which means we're probably going to use either DP, VD, or divide and conquer. I see the word subsequence, so probably DP. This mix and matches. Let's see. We define a harmonious array as an array where the difference between its maximum value and minimum value is exactly 1. Given an integer array nums, return the length of its longest harmonious subsequence among all its possible subsequences. Okay, since it's subsequence, can I do one of those things where I sort the numbers and the order doesn't matter? Sorry. Basically, I want every single number to be like a pivot point, right? Or I want to give every single number the chance of being the smallest one. Right, so something like unique numbers equals set of nums. For each unique number, treat it as the min number and figure out longest. This is essentially DP in its own, but like this is not, memorize the DP that I typically do. And figure out longest possible subsequence using that as minimum value. Is exactly 1. For num and unique nums. Res equals 0. If num plus 1, actually here we'll just say, we'll make it even better. We'll say d is equal to this. For num and nums, d of num plus or equal to 1 equals d dot get num, comma 0 plus 1. Not in D. Continue. Otherwise, res plus or equal to d of num plus d of num plus 1, right? Ooh. Actually, yeah, this is not going to be the case. This is going to be the number of ways. Yeah, this is going to be a wrong answer, but just bear with me here. Just bear with me here. Just bear with me here. Wrong answer. Weird that we get an extra. But the point is that it will be number of subsequences, right? So we have 2 options for each. Right, because it's exactly 1, so there must be at least 1 instance of each. Difference min and max must be exactly 1, not less than or to 1. So at least 1 instance of num plus 1 must exist. For each subsequence, we must keep at least instance of num and 1 instance of num plus 1. For the rest, we can either choose to keep or discard. So d of num minus 1 minus 1 2 to the power of this. No. Shrink num equals num plus 1 equals print f string d equals. Oh, it's not about the number of yeah, okay. Count equals this, print f string, count equals. No, I got 8 at some point. 1 and 2. Two and 3, I get 8. Oh yeah, now because it's not about, you're gonna want to keep as much as you can. You're gonna delete every other number in the subsequence. So this will just be count is equal to d of num plus d of num plus 1. Res less than count, res equals count, right? Basically something like this. That's kind of the point. Yeah, accept it, and let's submit. And there we go. You have been awarded DCC June 2025. Consistency is key. See ya next month. Okay, and this is actually kind of a special one because this will probably be the last ever DCC badge, monthly badge that I ever receive on this channel. Just because, as you may or may not know, today is 349, meaning that I'm only about 16 days away from reaching 365 days, 1 full year, right? Which will be, I believe, about July 15th, which means I will not be getting the full monthly badge for July, nor August, September, October, yada, 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 right? So June is the very, very last DCC month. So you know what? I will take a beautiful screenshot just for myself for the future. But yeah, so that's my last monthly badge right there. Gotta love the little spinning. 6, beautiful 6. So that means I did 6 months in 2024 and 6 months in 2025, give or take, which is kind of nice. Very, very nice, right? Yeah, very beautiful, very beautiful. Okay, that is it for June. That's very, very, very nice. Although, okay, so here, all right, maybe we can do things a little bit better. Yeah, let's get rid of the print statements. Yeah, the print statements are what was involved, right? Yeah, there we go. So now we're at 83.87% just because we get rid of this print statements. Okay. Here we could probably do a default dict event d of num plus or equal to 1 num plus 1 equals 0 and continue, right? Yeah, then we will not be doing that. My bad. Okay, submit. All right, 77, 83%. Okay, we're right in the standard deviation, which is exactly what you'd like to see. Okay, so nevertheless, as always on my videos, the recruit cap provides the solid prompts. So this one, we did get a LeetCode Easy, which really surprised me. For the last day of the month, we almost never get a LeetCode Easy. We usually almost always get LeetCode Hard or a bunch of sequenced LeetCode Hards. And since yesterday was a medium, I really expected to get a LeetCode Hard today. But you know what? I'll take it. I hope they don't punish us for July 1st, though. So let's see. This problem was essentially find the longest harmonious subsequence. We defined a harmonious array as an array where the difference between its maximum and minimum value is exactly 1. Not less than 1, not more than 1, exactly 1, right? So 0 doesn't count, so a length 1 array doesn't count because the minimum max is the same number itself, right? It must be exactly 1 difference. Given an integer array num, return the length of its longest harmonious subsequence among all its possible subsequences. So whenever you see the words longest and subsequence, whenever you see subsequence, you should think DP. Whenever you see longest, you should think DP or greedy or divide and conquer, right? Or at least that's what I do. Not always the true or not always the case, but a lot of the times it is the case. And so, oh, LHS, longest, I guess LIS is what I'm thinking of. Okay, never mind. Just the way they formatted the letters makes it look like a DP problem. I didn't really sub in DP in terms of like, memoization and so on, but the idea of DP here is very present in the terms that I solved this problem in terms of subproblems. So what kind of subproblems am I talking about? So here we want the longest possible harmonious array, where the difference between its maximum and minimum value is exactly 1. So what I'm going to do is I'm going to grab all the unique numbers inside of nums, and I'm going to remember their frequencies. So here I have a dictionary for each number in nums. I'm going to say d of num is equal to get the current frequency of num, or 0 by default, and add 1 to it, right? So that way, once I'm done with this iteration, I have a dictionary that maps every single number to its frequency inside of nums, right? Then here's what I'm going to do. For every single unique number in nums, so for each num in our dictionary D, we're going to consider that number as the minimum number of our current subsequence, right? The longest subsequence must have some minimum number, right? So I'm going to try each unique number in nums and do the case where that is the minimum number, right? And figure out what is that, because the actual longest subsequence must have a number in that subsequence that is the minimum number. So I'm going to try every single unique number inside of nums that I have as my keys of my dictionary D, and try each of those as the case where it is the minimum number in the subsequence, and see what is the longest subsequence I could get from that. Because once I've tried every number, then I must have end up found at somewhere the subsequence that ended up being the actual longest, right? Because the actual longest subsequence must have some number as the minimum. So I'm going to try every single possible unique number as the minimum number and figure out the longest subsequence from there. Okay, so here res is initially 0 for each unique number in D. Let's go. Okay, so the very first thing we see is that the difference between its minimum value and maximum value is exactly 1. That means I must have, well, first of all, the only way, if num is your minimum number, then in order for max num minus num to be equal to 1, well, that means that if you rearrange num on both sides here, that max num is really equal to num plus 1, right? If anything, I should have maybe called this min num. Here we say max num is equal to num plus 1. If max num, not in D, continue. Otherwise, count here. I'll just do this. I'll just rename my variables just to make things as least confusing as possible, right? But here max num will have to be equal to num plus 1. That way their difference is exactly 1. Okay, let's run this just to make sure I didn't make any typos here. Min num. There we go. I did make a typo. There we go. Oh boy. What did I do? Max num plus 1. Sorry. There we go. Okay, there we go. Now we have a working solution again. Okay, so just rename my variables there, just to make this. Ooh, okay. And by renaming, there we go. We get 96%. Crispy. I guess it's just like doing plus 1 twice is slower. I guess it's one of those where it's like only the O1 stuff is going to make you different to other people. So there you go. Okay, so for each minimum, we're going to consider every single unique number and make that our minimum number, right? We must have the difference between the minimum and maximum number be exactly 1. Not 0 and so on. So if I have just the subsequence 3, the minimum number is 3, the maximum number is 3, right? So 3 minus 3 is equal to 0. That is not exactly 1, right? 0 is less than 1, but it's not exactly 1. So that means we must have at least one instance of num plus 1. Here I'm going to rename this again. In order for the subsequence to have at least one instance of our minimum number, because we're considering those inside of our for loop, but we must have at least one instance of minimum number plus 1 and have that as our maximum number of the subsequence, right? So if maximum num, which is equal to min num plus 1, is not in our dictionary, that means there's no instance of it in nums, therefore we cannot form any subsequence using this minimum number. So in that case, we just continue the for loop. Otherwise, as long as we have at least one instance of max num, and obviously we have one instance of min num, otherwise it won't be in our dictionary D, that means, okay, let's form the longest subsequence where our minimum number is min num and our maximum number is obviously max num. Oh no, there's just a little smudge on my computer. Okay, I was like, what the heck? This looks like a curly brace like this to me, so I was like, what the heck? How is this working? Okay. Count is equal to, okay. So now, what is going to be the longest subsequence? Well, I'm only allowed to use instances of minnum, and I'm only allowed to use instances of maxnum, because if I use any other number that's larger, smaller, whatever, and so on, it'll mess up the difference between min and max must be exactly 1. So I can only use instances of minnum and instances of maxnum. Now remember, in our dictionary, for every single number, we kept track of its frequency. So how about I use every single instance of minnum, and I use every single instance of maxnum, right? That way I'll have the longest possible subsequence, because I'm going to use literally every single instance of minnum number that I can, and every single instance of the maximum number that I can. These minnum and maxnum, where maxnum happens to be minnum plus 1, right? So my count is literally going to be the sum of their frequencies, right? The frequency of minnum plus the frequency of maxnum, right? And I'm going to say, okay, that's going to be my count, right? The subsequence where this is the minimum number, and obviously this is the maximum number because I have at least one instance of each. And I'm going to say, okay, the sum of the frequencies will be the length of the subsequence, right? Where the longest subsequence where this is the minimum number. Then I'm going to update res if res is smaller than this count that I just found. If res is less than count, res is equal to count, right? So res is basically equal to res, the max of res and count every single iteration. Since I'm going to consider every single possible number inside of nums, every unique number inside of nums, as the case where that is the minimum number of its subsequence, knowing full well that the longest subsequence itself of the problem must have a minimum number, which must be one of the unique numbers in nums. By going through this for loop over and over, I will eventually find the optimal solution, so that way when I return res, as you can see, we have a nice working crispy solution. So hopefully that explanation makes sense. And yeah, but otherwise, that's pretty much it for this video. If you did find it useful and enjoyable, and if you perform, I'd highly appreciate if you left a like or a comment. Otherwise, I'll catch you in the next one. So till then, ciao ciao, my friend. Bye bye.